In Timothy C. Weingard's book, The Mosquito, A Human History of Our Deadliest Predator, the stunning impact of mosquitoes and the deadly diseases they carry and pass is uncovered. Humankind, over roughly the last 200,000 years, has been an incredibly successful species, with over 108 billion of us having existed. Yet, despite all of our success, one tiny, squishable enemy has single-handedly brought us to our knees. Of the 108 billion humans to have ever lived, 52 billion of them have been directly killed by mosquitoes. That's nearly half of us. And this is mostly due to the incredibly deadly cocktail of viruses mosquitoes are vectors of, from yellow fever, West Nile, and malaria to others such as Zika, dengue, I'm gonna say it wrong, Chikungunya. I'll put them down in the description. Point is, mosquitoes carry an incredibly high amount of very, very deadly viruses. And besides simply affecting death tolls, GDP can be seen being affected by outbreaks caused by mosquitoes, forcing workers out of the workplace. And this is in no way an issue mostly placed in the past. In fact, as many researchers have pointed out, since World War II, mosquitoes have not only become immune to DDT, their numbers seemingly stayed steady through radioactive and chemical experiences. Point is, these guys are tough as nails and have only grown more and more adaptive to humans in modern times. And the figure I've been avoiding is 2 million. It's the amount of people who die each year on average since 2000 from the bite of a tiny mosquito. And this is all happening alongside massive and effective vaccination efforts by NGOs such as the Gates Foundation, meaning essentially mosquitoes are still better at adapting to survive than we are at killing them. They're still coming out on top. But now in 2021, we may finally have the tools and the capabilities to fight back. So far, there seems to be two prominent solutions being posed throughout the internet. First, we genetically alter over 100 species of mosquitoes to not be able to carry diseases, which sounds great and is significantly more complicated than the other solution, which is to kill every last mosquito, or at least the dangerous ones, from the planet. So how would each of these solutions and the general mosquito issue work with our current grasp on science? How would we actually accomplish either of these ideas, and even should we? I mean, mosquitoes are animals too. This is For the Future of Us All Deep Dive. Why we should kill all the mosquitoes.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard. Because that challenge is hard.
But before we get into the video and freak you out about a bunch of tiny little insects, we'd love it if you would hit the like button and subscribe. Maybe even hit that little bell for the notifications. It not only helps us understand what kind of videos you guys are looking for on this channel, it also helps us with the YouTube algorithm. Thanks. So before we get into the different solutions to our mosquito problem, I think we should establish first what I mean when I say, quote, all mosquitoes. Because it's not really all of the mosquitoes. Mosquitoes are members of the evolutionary family CULICIDAE and have astonishing variety, claiming over 3,500 species in total. Which means you can probably guess that we don't need to kill all of them. Really, it's about 200 species that prey on us humans. Specifically, it's mosquitoes involved with Plasmodium, which is the protozoan parasite that causes a lot of the viruses that see issue with the human race. Think of it like if a mosquito is a weapon, the actual mosquito would be a sheath, and the protozoan parasite would be the sword. And this parasite is spread nearly uniformly by the genus ANOPHELES. And even within the 460 species in Anopheles, just over 100 carry the 5-ish species of Plasmodium that even harms humans. And further, even within this 100 or so, only 4 dozen at best are effective enough vectors to genuinely carry risk for us humans. And even further, only a few really prefer human blood to begin with, so it's not a lot of actual species that we're dealing with here. In short, it makes more sense to focus on the most harmful species within Anopheles, especially the species complex Anopheles GAMBIAE, which tactically would be far more effective than the total eradication of all mosquitoes. This is just for malaria, mostly due to its massive lead in deaths caused, but species of the genus AEDES carry arboviruses such as the yellow fever, West Nile, lacrosse, and Zika, among many others. And species of the genus CULEX also are prominent in the spread of bird malaria, and finally, the genus MANSONIA spread arboviruses that cause roundworms and other deadly diseases in the Pacific Asia region. Okay, so you must be thinking what I was at this point. Mosquitoes must do something for the environment. They're the part of the ecosystem, and we shouldn't mess with that. And under literally any other circumstance, I'd agree. But let me convince you. Adult mosquitoes provide food for a vast selection of animals and plants, from Venus flytraps to bats. Yet in none of these animals' diets does mosquitoes make up over 2% of its total nutrition. I mean, think about it. They're tiny and relatively difficult to catch. A worm or even a fly offers much more bang for your buck. And the one location where mosquitoes dominate the insect realm, the Arctic, yeah, they really do, only host non-human vectors, so no real threat there. Quickly dealing with pollination, no, mosquitoes are not so important in this realm to have any plants dependent on them. Okay, not completely true. A few orchids really love mosquito pollination and genuinely may not survive a total eradication, but they in no way are risking a global effect with their extinction. And before we get into the presumed effects of eliminating mosquitoes, you can probably understand why the two options posed in the beginning, sterilizing all mosquitoes or genetically altering them to no longer be vectors, are not easily the solutions, despite their apparent popularity on the internet. As I talked about, with the exception of the Arctic, the mosquito is not a keystone species really anywhere. It's a loaded statement, I know, but it rings true. So while taking out mosquitoes certainly wouldn't cause any other subsequent extinctions, remember at maximum they only make up about 2% of any animal's diet or plant. We are aware that the ecological niche, the corner in the house of life occupied currently by mosquitoes, would need replacing. It's a real spot in our ecosystem. And unfortunately, some of the contenders, such as midges, are just, if not more annoying than mosquitoes. And even some of them bite and leave a mark that's itchy for weeks instead of a couple of days. Yet none of them carry yellow fever or malaria as far as we know, and nearly all aren't vectors for any human disease at all. So it's a win, right? I really think so. Now, there is a chance that eliminating all mosquitoes could affect caribou migration. Yeah, you heard that right. Caribous intentionally don't visit areas with mosquito swarms, even though sometimes they're the best drinking holes or mating areas. And therefore, eliminating all mosquitoes could pose an effect on the migration patterns. These caribous could be traveling into areas they haven't before, which could change some of the landscape. We really don't know. I'll just say this though, caribou numbers aren't ridiculously high. In fact, they're a lot lower than they were before humans really settled Northern America, so And this is where what's called selective eradication, or taking out a specific group of mosquitoes, begins to make a whole lot of sense. And to achieve this correctly, we would need what's called an autocide, or when a species contributes to its own demise. And believe it or not, we've actually done this before successfully. The New World screwworm fly was a parasite decimating cattle production throughout the 20th century in America, leading to over $200 million a year in losses. Two scientists, Edward Kipling and Raymond Bushland, saw this and developed what's known as the sterile insect technique, where sterile males are released into a population, not impregnating females, and therefore lowering the population through a slow decline. This has now been developed into cytoplasmic incompatibility, essentially where we add the bacteria Wombutia that kills eggs upon contact with infected sperm. Ew, infected sperm. Gross. Yet this has issues as well. If the wild female mosquito that comes into contact with the infected male also is infected, their offspring will be immune. I told you guys, mosquitoes are gnarly. In short, this idea of targeted eradication has now led to RIDL, or RIDL, or release of insects carrying dominant lethals. And this really is the perfect strategy, as female-specific RIDL could potentially kill all female larvae upon impact, but allow males to carry the gene into adulthood, as only females carry the risk for humans, so these males could potentially breed with other females and continue the cycle for us. And this, in my opinion, is what should be accomplished with the vector-bearing species of mosquitoes. With no effect on the surrounding environment, we could save nearly 1 million lives a year minimum. But when we be honest, when you really get into the nitty-gritty of the science, we're still a while from being able to globally eradicate vector mosquitoes with RIDL or any other technique, so we have some time to think about it. Because there's a lot to mull over, the way in which we eradicate, if we even should, and what our place as the global ecosystem's puppet master means for our future. But my opinion will stay steady. We should absolutely move to kill all vector mosquitoes, as the damage of not far outweighs the risk of selectively tampering. And for the future of us all, we better get educated and find solutions.